is non-destructive tests and their importance in the investigation of villages. Strictly speaking, it is not non-destructive test. It is non-destructive, semi-destructive, as well as to a certain extent, at least a destructive. In the sense, we are not going to collapse the bridge in the form of a load test. But it is, we cannot 100% call it as this subject of non-destructive. Now, the investigation of structures using these non-destructive methods, there are two advantages. One is to investigate, absolutely check the structure's ability, structure's health, and other aspects of the structure. In addition to that, quality assurance also, while in construction, post-construction also can be made out using these non-destructive tests. The investigation, any investigation you carry out for various reasons, maybe health condition, maybe due to the quality assurance programs, that's all is the post-construction method. The quality assurance in construction, the quality has been defined as a totality in features and characteristics of a product or services that bear on its ability to satisfy or implied needs. This is actually the quality meaning. The quality has to be taken in three-pronged strategy. It specifies the acceptable material construction, that is acceptable level. And it defines various design criteria also, practical rules, sound engineering practices. It deals with the workmanship and other aspects of the construction. And non-destructive tests can be conducted either on the concrete or on the steel. Anyone. It has to be conducted separately also. And completed structures like pile foundations, I was just explaining the chief engineer about 1 hour back. Pile foundations also can be done by non-destructive tests. It is a lengthy, big. Earlier there was no non-destructive test. Now it went on adding. So much instruments have come into the market, and they have also been codified. In India, we have the Bureau of BIS is the code committee, plus Indian Roads Congress is also one more code committee. In addition to that, we also have the ASTM, where we don't have the Indian codes, we refer the outside codes. Outside codes, whenever that thing arises, like dynamic pile load testing, or some places where we do not have. That dynamic has come very recently into the Indian IRC codes. So we have codes also, equipments also slowly getting into the market and getting into the civil engineering field. That makes our life a little bit easier, because without cutting, without opening, you can find out the structure's ability to take the loads, structure's health condition, structure's quality. All these things can be made out using this. And structure, if it is in distress, like thermal photo imaging. Thermal photo imaging is an excellent method of finding the fault in a structure where it is about to collapse or it is in a highly distressed condition. And also, these non-destructive tests are also there to locate the services below the road surface. See, when you excavate a road to put some service or whatever below, invariably you will have to run a GPR, ground penetrating radar below, on the top. You can easily make out how many service lines are crossing there. There may be 11 kV electrical lines, water supply lines. There may be so many lines passing on below your road, and you need to make out what exactly and how exactly lines are passing, so that you can plan your excavation, underpasses, bridges, bridge foundations, you can plan later. That's the reason you do this non-destructive test. Probably here in the Raipur, I don't know, this is becoming a common test in other places, like in Bangalore, Mumbai, Chennai, Delhi also. They invariably go for ground penetrating radar. I will show you the picture. It is simply you just pass a four-wheeled small vehicle on the top. Immediately you will get and here about, you can see about say 30-40 feet also. About 10 to 15 meters you can see here in your computer when the radiation, when this ground penetrating radars waves pass through down and they get back. It is an absolutely useful equipment, practical equipment for our road engineers. Now the fundamental one is, I will not ask about GPR because GPR is yet to come, I think, in this side. I will ask this question, rebound hammer test. How many of you have seen this and used this rebound hammer here amongst entire 1, 2, 3, only 3, 4, 5, only 5. All of you have used this or only seen? 6. You used? You have seen this. You have seen this rebound hammer test. This rebound hammer test, actually, my experience, I will tell you, somewhere around in 1983, in one of the bridges of national highways, the strength came less in one of the well steenings. It came less than the specified. Maybe I think about 30-35 is specified. We got about 20-25 or so. So ministry has asked, verify properly using any other methods. So that time only we came to know that there is one more method we can do this non-destructive. Then we searched in the market. Somehow we could catch this. That's almost about 40 years back. We caught this. Somehow we managed to get this from, I think, Mumbai or Delhi. Those days only. Then we took a boat in the river surrounding the well foundation. Then hit there. That time there was the first time I have used and known this rebound hammer. Oh, this can be used like this. Those were the days. And this is absolutely useful equipment. Especially this can be used only in the recently completed or late completed structures. This will give a bad results when you use it on old structures. You should not rely much on this when you check the old structures for their health. Only if you want, you can just write down in your books that this is the result. Do not use the results of this test in your reports. And we have the IS code for this 516 is there. In detail it is given. 100% detail, so much so it is when it is got revised recently, very detailed it is given, and you can go through that 516 IS. And suppose you are doing this precast members anywhere, precast small components, bridge components, or whatever, even roadside drains, M30, 35, if you want within 2-3 days the strength. This is the best instrument. No need to depend on your cube testing equipment. This is one of the best equipments, and invariably majority of the PWDs in this country, they own this equipment. Not one, many they own. All quality control laboratories, assurance, and the ownership, like PWD owners in Karnataka we have. They are the basic owners of entire asset management. They own this. If you do not have this, I do not know, but if you do not have this, make a plan. It costs hardly about 50,000-60,000 or less than about 75,000 rupees. This is basically, if you are buying, you buy an imported one, Switzerland. Even Indians also available. Based on my experience, I'll tell you, Indians, we don't manufacture so precisely. That's a problem with us. And this Swiss make will give you absolute good results, accurate. Then we have one more. Sir was telling in the morning there's ultrasonic pulse velocity test. I just take it a little bit, 2 steps further. Ultrasonic pulse velocity test, you see here, there are 2 hands on the right side. On your left side photo, on this photo, on that photo, right side photo, there are 2 probes, steel probes you can see there. And before going through, can I know how many of you have used this or seen this? Oh, good. At least about 5-6 people are there. You have used? You tested? No. At least you have seen. Good. Yes. See, left and right hand, somebody is holding those 2 steel things there. They are probes. One will send the ultrasonic pulses this side, other one will receive that. So time taken to pass from this end to that end is measured by this instrument. This instrument is there to measure the distance travelled between 2 transducers, and it will calculate the time taken. So when we actually calculate what is the distance, means this may be about 300 kilometers per second. How many kilometers per second is taken? That's the calculation. 516 also says about that. And less than 3.5, now it is upgraded to 3.75, I think, kilometer per second is considered as poor. Means it will have to get a higher velocities, because if it is a stronger, the speed of the ultrasonics will move faster. And with this is such a fantastic equipment. Invariably in all metros, superstructure metros, invariably they put this in the equipment in action, and repeatedly they do that. Suppose you get some corner, something has failed, they put the ultrasonic equipment. If you get less than 3 or 2 or 2.5, immediately you can make out there is a honeycomb inside. Inside there is honeycomb, some problem is there. Immediately they will go for low viscosity epoxy groutings, and again they will test with the same equipment for whether their rehabilitation done is proper or not. That much they take care, and this gives such results. Even you can make out if some crack is there. If at all you want to know how much depth it is there into your structure, you can make out using this equipment. And if your QC, quality control laboratory, if you do not have, kindly make arrangements to get one of this. This I don't say that you buy from the Switzerland man. And now Indians have started, and we have fairly better, some Bombay companies are there. You can buy that. It costs hardly about Indian about 2.75 lakhs. That's all. Whereas the Swiss make, I think that costs about 3 and odd, in that range only. It has got so many other parameters, and for that to get those parameters, they may charge more. But this is one of the very good equipment for your quality assurance, quality control things of your structures. Please feel free to ask me back. Suppose on this, if you want to ask some questions, feel free to ask me, because I will not be blaming you that you don't know anything. How come? We will never tell you. We have come only to educate, here to expand whatever you know much better. Sir and myself, we are here only to do that. So don't bother. If you want Even any questions, there is no problem. Yeah, we take you as our co-engineers, and we will never tell you, oh, you don't know only this much. No, definitely no. Because at your age, we are not knowing what you know also. So don't bother, feel free. Now coming to the carbonation or reduction in the pH values. Here, and this is not a quality assurance tool, but an investigation tool. This carbonation, we have started reducing the word usage for the carbonation. Nowadays, as Sir has told, phenolphthalein solution is sprayed on the concrete to check whether it is carbonated, not carbonated. Everywhere, now that is a trend. Whereas, as civil engineers, as bridge engineers, as structural engineers, what we should say is not the carbonation, we should say what is the pH value of the concrete. Carbonation happens when the pH value of your concrete comes down from 14. 14 is your fully alkaline concrete. It is a lime, full-fledged lime, 13 to 13 and a half, 14. When it starts coming down due to this aging process, after completion of your structure, the 13 will come down to such a stage, maybe about 8, 9, 10 in that range it comes. With this phenolphthalein solution, it comes, you can make out it is less than about 10 or 11. That is carbonated. Carbonated means it will not give any protection to the reinforcement inside. So pH value, we don't say carbonation, we say pH value is less than say 10, 12 in that range. Then how far down it can go? 9, 8. Then what is the effect of this pH on our structures? This pH effect, it is quite a serious one, and it is expected to go down to whatever extent possible based on so many factors like your environment, your manufacture, your so many things. But based on our observation of about 30 years and odd, this subject, this subject, where the pH has not reduced for older structures, say they were manufactured, means they were constructed around 1970s, 75, the pH has not gone down below 11. Below 11 based on experience, because when we check, when we took out the samples, we'll send it to laboratory for testing, and this is a very important statement what I am making. 70, 75s, the pH has not gone down below 11, 11 and a half. Whereas structures built somewhere in 2010, 8, 5, in that range, the pH has gone down. Probably in one of the slides I will show you, not one, multiple slides are there. It has reached below 8. Below 8 means 7 is, 0 is acid, 7 is neutral, 14 is alkaline. I think all of you know chemistry of this subject. So if it comes to 7, it will not give absolutely any protection, but it is expected to split also, or it may give away, it may give away the concrete itself. It will not give any protection below 8. When you take out a core, get it tested for the pH value, you just check that. Now coming back, 7.5, 8 when you get it for the structures built recently, whereas structures built around 1975, they are still safer at 11.5 pH value. What is the why this trend? Older structure is supposed to get lower pH values after some time, more time, whereas the new structures are getting this type of faster pH reduction. That means that they are unfit to become regular structures. They will go for rehabilitation quickly. Then we went backwards, checked up all the records, checked up backwards, checked so many things. How it is reducing for 1975 built structure, so high pH is there, whereas 2000 structure so low it has come down. How and why? Reason. When we made the reason out, probably that has not been done by anybody else till date, by any scientist or so. What we found is, while manufacturing the cement, 1975 and backwards, they were using the wet method of manufacture of cement. After 75-80, based on our need for electricity and input material cost was quite higher, they went for dry method of manufacture of cement. And we are still going through the chemical analysis. Probably it will take some time. Probably after some time we will be publishing a paper in FIB journal. That will be a it is a breakthrough in the pH value criteria of the structure, as well as in the analysis of health condition of structures. Please note, when you go to the structure, when you go to the site, suppose somebody asks you whether can we do this rehabilitation, sab kar sakta hai kya? What you do is take out a core, simply take out a core, take it out, cut, make pieces, go for the chemical analysis, chloride, pH and sulfates. First you get that. Once you get the pH value, then you say yes, this can be done, this cannot be done. If it cannot be done, if it is below 8 or 8.5, leave for 5 years, afterwards you demolish that. That will be useless. There is no need to do rehabilitation of each and every structure. Below pH come ho gaya to you cannot repack the pH into the structure. There are methods, but those methods are that takes crores and crores to put back the pH. So my suggestion to the field people here is, take samples, go for the chemical analysis, and probably you may be here in Raipur, or if you have your own laboratory or nearby Bhopal or anywhere, check the pH values, then you enter into the rehabilitation process. Then further going, after pH, in the chemical analysis, you will have to go for the chlorides and sulfates. The Bureau of Indian Standards has given the limitations. How much chloride should be there, how much sulfate should be there, the limits. Beyond that, if the contents are more, chlorides, they will start corroding process in the reinforcement. Corrosion process by chlorides is very dangerous, and it is expected to destroy the structure at very high speed. And there is a connection between the chlorides and the pH value. There is a link. If so much chlorides is there with a lesser pH, again corrosion will start. There is a linking in that. See, like this, if you have a pH of 13.5, even with a very small chloride content of 6.7, that is about 6000 ppm, it will start corroding. sorry, it is higher with such a higher also, 13.5 will not have much damage. When it comes down, you come down to the 10, pH 10, even with 2 chlorides, a very small quantity of chlorides will start damaging the structure even if the pH is less. That indicates you should not allow the pH to go down in the structure. This is the approximate graph, somewhere we managed to get it. This is the actually a combination of chlorides with a ppm and the pH value. This is a excellent exercise if you can understand. Yes, sir.
This chloride contains 6.74
Yeah.
per liter.
Yeah.
Is it with respect to the water which is going to increase the what? What is the 6.74
Grams per liter. In the concrete.
in the country?
In the concrete, whole concrete. If the yeah.
See, if the chloride content is so high, then how can the pH will be 13?
Yeah, no, this is only a comparison, sir. This is comparing if the
The chloride has already gone so high.
yeah, even that will not get damage the 13.5 fellow, because with the heavy chloride also this pH will take care. So that is a combination shown here. Suppose it is 11.5. 11.
My understanding is that if the cement when we are testing the cement, and if the chloride content is more than 500 ppm having 0.05%, it is prone to carbonation and corrosion.
Yes, sir. No, that is.
And if it is inbuilt in the cement itself,
Yeah.
then the pH, even if it is in the initial stage is 13.5,
Yeah.
it is going to reduce drastically.
Yeah, certainly, sir. This is only a comparison. Suppose you have pH this, so much of chloride, then also it will not damage. Suppose it is less, more. It is only a combination. Suppose if it is say 12 or 11.5, with 67 ppm it starts corroding. With 10, it is with 2 is sufficient. With a small 2, because pH is reduced so much below. So what we wanted to say is pH is the prime factor. We should not bring it down to such low levels. Even with a small quantity of chloride, it will start damaging. Anybody, any question? If you have understood and not understood also, it's okay. You feel,
It's very serious, as you said.
yeah,
The very manufacturing of cement,
yeah,
if it is responsible for poor concrete and poor structures,
yeah,
then probably next 15 to 20 years it's going to be a havoc.
yeah. Sir, what we have, I will show some more, sir, where we have investigated structures, where the pH has gone down so badly, and majority of this nowadays structure only. When we check the old structures, like old bridges are there, plenty of bridges are there in Karnataka also, other places also, where this manufacture or the construction date is 1975 or behind, pH has not gone down at all. And why? Reason, when we checked the reason, those days cement manufacture was wet process. Of course, that was not a cost effective, because energy input to the manufacture of cement was great. A huge quantity they used to put either the coal or the electricity. Then they shifted towards this other method, and we feel the suspect is there only. Suspicion lands there only, and probably we are already working out on that. What must have gone wrong with the chemistry of this and chemistry of that? What must have gone wrong? So probably we will come out with some sort of this one. Of course, it will be contradictory. These cement manufacturers will never agree on all such things. They will come back and they will tell 100 things. No problem. Whatever we feel.
Any study with respect to OPC and PVC? Because in PVC we we are adding the fly ash,
Yeah.
right? And the OPC is the.
All majority is OPC only, sir, here, because, no, PPC only here,
Yeah.
because earlier also PPC was there, and 19,
Earlier 70s structures were only with the OPC.
that was only, no, OPC only, sir.
Yes.
That they were all OPC, even today also, ordinary Portland cement only, except for 53 and 43, leaving that, there was not much of a difference. The adding of the other ingredients there, that is only recently. And especially when it comes to RMCs, they started using more and fly ash.
Will it affect you durability?
Sir, actually to speak, if you add the fly ash, your pH will come down. How much? From 14 or 13 and a half to half it will come down. Say about if your OPC is giving 13.5, when you add this it will come to 13. And we don't have much data about say after 10 years how it is working and all. We don't have much of the data. Probably we will get after some time, maybe about after 15-20 years we can make out to get all those data, so that usage of proper cement into the concrete can be regulated. And now further going, profometer test. Again I am asking, how many have seen this equipment, profometer, and how many have used or at least seen in the entire audience? Sir, time has come for you to put up on laboratory and get the people trained, because these are all the basic major important tests. So, aapka contractor, you should be careful enough. And if nobody has seen, these are all, again I will tell you, sir, this should not cost about 2 to 3 lakhs. And again I am telling you, this is a Switzerland make. Better to buy either a Swiss make, like that we cover. Profometer is nothing but, this equipment is nothing but, you will find out the diameter of the reinforcement and the cover, how much it is from the surface. Both the things you can make out from this. Yeah, certainly spacing you can easily make out. There is no problem at all. Because if you have bars here, if you put the equipment here, that you see that yellow thing there, yellow thing there, you put here, slide it off, you can exactly mark it there. Yes, 1, 2, 3, 4, 5, 6 bars. And if you mark in between bars, if you bring it down like this, again your distribution, 1, 2, 3, 4, you get all that. And if the cover is smaller, if the cover is very big, accuracy will go. But you can make out, oh yes, there is a bar. If the cover is bit lesser, again if you keep it there, that equipment has got some, this one, to put some buttons there, immediately it will show 25. You can make out what is the diameter of the bar inside. You put here, you can make out. No, some sort of an evidence you get using this equipment. And we have done plenty of, so many hundreds and hundreds, except when the cover thickness is bigger, like 50, 60, 70 or even it is 100 mm thick is there, you can only make out a steel, that's all. You cannot make out the diameter. Diameter you cannot see. If it is on the surface, it is coming outside near the surface, then you can make out the diameter of the steel reinforcing bar. Very useful equipment. Sir?
What only up to 100 mm?
Space, cover.
No,
No, you can make out about 100, 120 you can make out. That's all. Afterwards it will not show. Because it will send some waves, it will get back. So after this, it will not show. It will not show, but our majority of our reinforcement in our structures is hardly about 50, allowed is for 40, sometimes 60, 70, that is sufficient for us. So some sort of this one plus what is, if you have that in your laboratory, if you have, what you can do is, suppose you want to take out a core of the concrete here. You want to take out a core where your bars are there, plenty of bars are there this way. You can scan using this, and wherever the bar is not passing, make a round and put that core cutter there and remove the core and fill it back. For that purpose also this will be useful. This has got a Bureau of British standard. I think we don't have our standard. Why standard is required? Because each and every instrument, if the standard is there, it has got the backing. So this has got a British standard. And the corrosion of steel in the electrochemical reaction, I have already told you. And we have two types of corrosion finding equipment. We have two types. One is electrochemical half cell potentiometer. That's the first one what you see there. Electrochemical half cell potentiometer. And then we have the resistivity mapping by resistivity meter. Both the equipment can be put into the service to get the corrosion potentials. Suppose you have, this is a column or this is a beam or whatever it is, and you want to know what the reinforcement, whether it is getting corroded, and looking wise it is good. वो अच्छा दिख रहा है. We do not know whether it is corroding, but you have a suspicion अंदर कुछ हो रहा है. You have suspicion. लगता है उधर है इसको क्या हो गया, लगता है there is nothing here. So what is the problem? Take this equipment, electrochemical half cell potentiometer. Yeah, this one. As you see there, fix all the gadget and all put together only this much. All put together only this much, and I will tell you this cost also is about 4 to 5 lakhs. This much. उसको you fix it somewhere wherever this reinforcement, somewhere there it will be get exposed, or you drill a hole, उसको एक negative wire डालने का, then bring your regular that equipment on the top. What you see left side, you see that negative connection, something is there, that is a cell. You bring that, on this you keep moving this. When you move this here, you start getting that voltage there. You see 0.1 is there. There you get negative millivolts. Always the reinforcement corrosion is read in terms of negative millivolts. It will be 100, 50, 200, 300, 400, 1000, 2000. Suppose, what is the level? Bureau of Indian Standards has already given the level. 250 to 300 so it is slightly getting corroded, and 300 to 350 it is more corrosion. There is already we have, see that 516 is given there. There we have the table, which is a more corrosion, less corrosion, all details are there. Based on whatever our experience is there, based on my experience, if it is 300, 350 negative millivolts, yes, inside corrosion लाल हो रहा है. You can open and see, there it will be red there. If it is 400, it will be more and more corrosion. 500, 600, you can easily expect वो थोड़ा delamination का start हो गया. 800, 900, the code doesn't say about 800. The code stops at 350. That's all. You will not say. But when you do a structure, investigation structure, that time, if it is 6, 7, 800, 900 like that, you can just certify, yes, inside is corrosion. Take a drill hammer, अंदर डाल के you can easily make out, take a picture. So this is the usefulness of that. This equipment is so much useful. There is no need for you to wait till this cover concrete falls. There is no need. You immediately can make out, yes, this is under corrosion. This is under corrosion. Something has to be done. What? Based on your experience or rehabilitation methods, you will have to do some exercise. So this will be of, and this has got base is copper sulfate, saturated column electrode. The name they tell that, and that whatever the cell is there, that is copper sulfate. Copper sulfate is liquid. Copper is that rod there. That will show the current potentials, what is going on. If the corrosion is happening, there will be some electrical potentials going on full speed inside, and that will be, it will emanating all the potentials which will be picked by this small fellow. So with that, what happens is we will come to know exactly, yes, this is what is happening. My question to my friends is, how many have seen this test? Nobody. When you see, sir, actually if you make your staff to use themselves, they will feel so happy. What is they are showing so much, and they will show a lot of interest after that. This is similar one, resistivity meter. Almost a similar one, but a different methodology altogether. And this is also for the corrosion activity. And corrosion, you can see there that whatever the lines there, they are the potentials. A higher potential is there, that is drawn separately here on the left side. And again, resistivity, second one, as I told you, first one I explained about 300, 400, 500, 600. Whereas in this resistivity, if it is ohm centimeter, if it is between 5,000 and 10,000, it is high. Less than 5,000, it is again very high. Then we have the code for that. No need to bother. We need to pick the resistivity factors. Again, one more non-destructive. I have a list of non-destructive tests there. This test, if somebody has worked in hospital, somebody has got a doctor in the house, they will come to know about this endoscope, because with this endoscope, in a pre-stress cables or somewhere where we can put those pipe inside, we can slide the pipe inside and we can see from outside exactly what is there with a magnification glass or whatever, and take a photograph, videograph, whatever you want. This is extremely useful, especially in the field wherever we have problem with pre-stress anchor hua, nahi hua, there is some issue with whether it is a post-tension, pre-tension, lot of sites we cannot make out. Only span we can see. Finally we will end up whether it is RCC or PSC. The way in which it is mentioned there, the way in which the size is there, we can say mostly it is RCC. Mostly. When actually then check there, check here, check there, beat there, remove there, it is pre-stress. And that was spaced very closely. Now with the experience also it is quite difficult. At that time, if some small space is there, we can put this pipe inside. This endoscope will come for extreme useful. And whatever mentioned reference is IRCSP 80. Yeah, I don't have that. I was also one of the code committee members there in the IRCSP 80. That will give you all sorts of details about that. And also you have this IRCSP 40. 40 guidelines on repair, strengthening and rehabilitation of concrete bridges. In this also we have mentioned majority of tests You can see here, majority of tests, whatever mentioned there like this. Almost all, like see, just now you have seen this. This is already there in IRCSP 40. That's the reason I told you, थोड़ा खर्चा हुआ तो भी चलता है. And especially for the PWD sake. In fact, in one of the technical advisory committees in Bangalore, I had asked IRC, पूरा book भेज देने का. Whatever the recent publication is there, 100% you send it for our library. So like that, in case you have a library, that this will be of extremely useful. Now coming down to the, sir, somebody asked this pile integrity test. He is not there, I think. He has asked for the pile integrity test. See, with this one hammer, one hit, you will come to know what is the length of the pile, what is the, how much damage it has gone through inside. See the pile, the shape. It is in such a bad condition. You can make out using this equipment. And we have a code also written for this purpose. And there is one more dynamic pile load testing. Probably some of you must be aware of this. How many of you are aware of the dynamic pile load testing? You know that? Yeah, you know. Yeah, oh, okay. At least you are there. Now, this dynamic pile load testing is not a replacement for your static pile load testing, I am telling you. This should be used very rarely with IRC 78. 78 clearly tells you should use like this only. You should not straight away jump into dynamic pile load testing and start doing that. No. You will be doing wrong. And you are going against the code. Audit is there, then they will take care very seriously. There is no replacement for static pile load testing. Physically, you must press. You people are all bridge engineers. Physical, unless until it is not possible, impossible, or there is some issue there, then only with a special permission you can go for this dynamic pile load testing. Or else you do about 7-8 dynamic pile load testings, 8th, 9th, you can start doing this. Not jump into the first one itself, you will go wrong. It might give results, but it is, no, physical pressing is compulsory as far as bridges are concerned. Then you have this, it's good to see at least the dynamic pile load testing. Some people are already into it. Then you have this infrared thermography. What is this infrared thermography? Thermal imaging. It is such a useful thing. Suppose you, sir ne bol raha tha, when it goes down, when you bend a structure, you get some cracks in the middle, shear cracks at the edge and all. You bend it, when you bend it, this beam will start emanating heat because you are overstressing it. And before any structure, suppose any structure is falling, collapsing, or your bridges are under stress, बहुत stress में रहा है, crack हो रहा है, something it may collapse maybe in about 2-3 days. Definitely it is a small one, the handheld, immediately it will show the temperatures are much higher than ambient temperature what you see here. We have used this, it is very, very useful. And in Hyderabad, I think they used, before collapse of one structure, they used this with a full camera, 100% they made, they took the details, they got all heated up, fully heated up structure, fully all joints. First which was collapsing, that was highly heated up. So this will be of very much useful. I have already told about ground penetrating radar. This is the one with like a bicycle, it has got a control unit in the top, then an antenna at the bottom. Of course, there is a battery and all. And these ground penetrating radars can be used to make out even at 10 meter, 20 meter below ground, what any pipes are there, and or any services, any problems regularly used. And this is a part of the lecture. I expect some questions from you. Where all can we use this? How do we use this? Because there are so many equipment. How to put this into usage? These are things what I expect from you people. Yeah, tell me.
Sir, why is rebound hammer test not suitable for old structures, sir?
Yeah. Why? See, this type of questions will make us to go further and check out and answer your other people in a better way. So this is exactly this type of question. Not only rebound, you ask me other things also. If I know, I should be able to tell you. See, what happens is, rebound hammer test, you are putting on the surface. You are putting on the surface, you are hitting the surface, it gives the surface strength of the concrete. There is, after some years, maybe after 5 years, 10 years or so, the surface, concrete surface will start hardening due to weather conditions. It will not be the same like when it was manufactured. Like when you casted it, it will not be the same. Slowly it becomes harden and more harden. If at all you have casted already about 20, M20, 25, after 10 years, 15 years, you just check it, you will get about 35 or 40 or even much more also. So that gives a wrong result. That's the reason we told, don't use for an old one. That is very much fit for a new one of 6 months or 1 year in that range. That's the reason. And some of you may ask me, what is the use of ultrasonic pulse velocities? If it is a crack, you can make out how much depth the crack has gone inside the structure. You can make out using this ultrasonic. How do you, he has given, that manufacturer has given, you put probes, take this reading, again put probes, take this reading, and you interpolate, you will get the results. This has been already told there.
Sir, why that dynamic test is a failure?
Sir,
Dynamic plate load test is a failure. Why?
Dynamic pile load.
Why we can't rely on dynamic test?
Yeah, dynamic pile load test. Sir, in bridge constructions we use extensively piles. Now earlier days we have only wells were there. We have shifted over to the piles because we got a lot of people who manufacture piling equipment, easy to do. We take the equipment on the site and we do it. But when it comes to the pile load testing, what we say is, in any of the bridge structure, Ministry of Road Transport Highways, what it says, that book, orange book, you will have to put 2 initial piles there at one side, wherever in the bridge side, then take out the readings, then you go ahead. Those 2 readings, see, there is, suppose you know fully well, there is no need to put anything. Now why they are telling is, we do not know how the soil structure interaction will take place in the entire stretch of the bridge. We do not know. Now, if you theoretically, it is not possible. Now, with this physical application of the initial pile load test, you will come to exactly, yes, it is taking this much of friction and this much of end bearing separately. And nowadays, for your information, I will tell you, since you are asking, there is one more test called bidirectional pile load testing. Bidirectional pile load testing, you need not put that whole of that cartilage. I think you people know, huge sand piles, sand they put there, they go below, put the jacks. How many, I don't know how many I have seen there, you have seen, yeah. Huge, they put it, or they put the anchors. They put the anchors, put the jacks, then stress it. Now what happened is, there was an agency from the West Asia regularly coming to Bombay and Delhi. He was doing this bi-directional pile load testing. Charges were almost similar, about 10-20% more. And there is no need for you to put that bigger anchors or that sand. Nothing is required. In the pile itself, he will cast the jacks. Jacks are inbuilt in the pile itself and it is casted. Then once it is completed, then he will put pressure. He will put pressure so that the top portion jack will move upwards against the bottom one. So you get bottom pressure as a resistance below, and top pressure, it is nothing but friction. And it has already been written also, code ASTM. And by chance what happened was, when this code was under preparation in ASTM, I was also an ASTM member. Even I am now also I am an ASTM member. So I thought that yes, because that agency from West Asia was coming, he was billing dollars in India. We had an eye, yes, why he is billing dollars? That means he is taking away our dollars outside, and our technology is getting down. We must do something. I worked almost for about 4 years. I went to Europe, I went to China also, only to get this, how to manage to get this. By the time ASTM was also under preparation for the same code, bidirectional, I thought that we should introduce earlier than ASTM, because I was also a member there, I knew what is happening. In IRC we introduced, we got it passed. In Bangalore session it was passed, and now it is already inside your recently whatever printed 78. This bi-directional pile load testing, it's a very important one, and there is no need for you to put the cantileges, no need to put the anchors. All will go inside only. Only thing, it is a sacrificial method. Jacks will get sacrificed there. But cost is, if the cost is slightly here and there, why not? And as you said, these piles, these two piles, why we put is because of that only, because we don't know anything about inside pile, and the style structure interaction is required. That's exactly the reason.